So, dear friends, welcome again. In our previous sessions, we have learned about the different type of 3D printing, overview of the 3D printing, and then we have seen some of the applications in mechanical manufacturing and some of the areas like in veterinary application, how we can use these 3D printing technologies to the benefit of the mankind. Now, in this discussion that I will be taking in this particular session, we will be talking about the development of in-house material, which is basically having some customized property. Like specifically in this case, we are working on a PLA polymer in which the reinforcement of hydroxyapatite and chitosan has been done to ensure the biocompatibility, biodegradability, and basically we want to use this for a wound healing application, right? So how to use this, how to make this filament, that is the idea of discussion. So we all know that the biocompatible and biodegradable composites are really need of the hour, and the twin screw extrusion is one of the established process for this. So polylactic acid we have used, in which we have reinforced the hydroxyapatite and chitosan. This chitosan is basically from the fish bone, and hydroxyapatite we collected from the market. Again, we can use it from the eggshell also, but in this case the commercially available powder of hydroxyapatite and chitosan has been procured from the market, and then we reinforce this hydroxyapatite and chitosan into the PLA matrix to twin screw extrusion, and finally the fused filament fabrication or the FDM process has been used. Now, what is important in this to understand about the process? As you can see, this is the setup available in our lab. This is the twin screw extruder, and here I am basically putting the die, and finally this is the extruded that is coming. Now you can see in this case, this is showing PLA 91 HAP 8 chitosan 1. This is basically the weight proportion, 91% PLA by weight, 8% hydroxyapatite and chitosan. As per the reported literature, if I am reinforcing the hydroxyapatite from 8 to 10%, that is acceptable for fast wound healing. Similarly, chitosan from 1 to 2% is recommended. And then in second case, we try to work over the hydroxyapatite by putting 8% and chitosan as 2%, and overall this has been made as 98 and 2. And based on this we went for different combination as regard to the thermal analysis is concerned. For 9181, 98 to 84 fourth is basically to understand what is the effect of this material composition on the crystallinity, on the glass transition. And what we observed that 98.2 was one of the outstanding material among the other three. In our one of the discussion, maybe in the first week, we have learned about this DSE diagram when I was discussing about the case of the dry cell. So I think one can easily understand from room temperature to 150, we are heating, then cooling, then heating up to 150, then coming to the room temperature, and seeing what is the effect of this processing condition on the crystallinity, glass transition, melting temperature, and how stable this type of material is. So out of this investigation, 98.2 composition was considered to be one of the acceptable. Then we try to prepare the filament and try to see what is the the behavior of this type of material when I magnify it and see it in a scanning electron microscopy. So what we observed, when I see at a high magnification, the lot of porous space and interconnectivity of the fibrous structure is observed. That means whenever there will be a bone growth, there will be a sufficient space for the osteoblast cell to move within this space, and this will help me in developing really a good bond, and is considered as one of the acceptable material, specifically in case of the bone grafting application, or I want to use let us say some of the implant or some of the sports structure. So this can be one of the useful application. See, in this case, the beauty is the PLA is biocompatible as well as biodegradable. So if I am interested in the secondary stability of some side of the orthopedic or the dental implant, so this will be one of the really useful solution that can help me in making a solid structure more robust structure. So that is the basic idea of working in this. Now continuing my discussion, we talked about in the second week about the 4D behavior specifically for the exotic structure. Now we learned about using different 3D printing technologies, which may be a powder based, which may be a polymer based, which may be a laser based melting, right? And we talk about the 4D behavior. This particular slide I have shown you earlier, in which the one way, two way, and multi stage programming we try to explore. Now, using the concept, now we want to actually implement this into the any useful product. Like for the 4D and specifically for the exotic, we discussed that there can be different type of stimulus. It can be in the form of electric energy, magnetic field, mechanical load, in the form of light, in the form of some chemical energy, in the form of some temperature. How we can use it for development of a smart product, right? So to develop that, I need a initial setup. First is the rheology. So I need a MFI setup. So this is the one of the melt flow index setup, which is based upon ASTM 1238D standard. This is the twin screw extruder. I have already shown you the actual picture, and this is the schematic of the FDM process. Right now, what is the live application? So we got a very interesting project. Like we want to develop some material as a replacement of the wood, which can basically be a good insulator for the heat. Actually, this was a live problem in Saskatchewan, where the outside temperature is -40, and to conserve the heat, we want to replace some wood with a thermoplastic based material, and we want to have some 4D characteristics that it can be used in the form of the smart tiles, right? So if I use a PVC paneling like that, so then it creates a different type of problem, because this PVC material after some time may not be giving a good color luster, and finally I have to remove it. And of course sometimes the fumes may not be really good for humans. So what we did is we selected the PLA, then crushed form of PVC, and we use a magnetite powder and the wood dust, which was all these are available in the form of waste, right? So we prepared the filament independently, and we tried with the different proportion. Like we started initially with a PLA with 20 gram, let us say the 50 weight percentage, then PVC magnetite powder. This is basically to sensitize the material. Basically, I am interested in the use of the magnetic field for basically the 4D behavior, and then the putting the wood dust basically for the better insulation. So we tried with different combination and tried to prepare the filament by using a DOE, and we have the parameters like varying the torque, varying the screw temperature, varying the applied load. So this is the range that is available with me, and we tried with one L18 orthogonal array and try to prepare the filament using these type of composition. And based upon this, for all 18 set of the filaments that were prepared, we try to see what is the magnetization, what is the corrosivity, and what is the retentivity. So as a typical mechanical engineering application, so magnetization is basically how easily I can magnetize. Then if I switch off the magnetic field, how long the magnetic field will be remain in that particular material, that is representing the retentivity. Then if I want to just reverse the direction of the magnetic field, so I have to apply magnetic field in the opposite direction, so that is basically representing the corrosivity. So I need a best condition for magnetization. It should be easy to magnetize for corrosivity as well as retentivity. So we develop the BH curves to understand which particular composition is better for giving me the stimulus effect of magnetic field for typical 4D application. And we used some NOVA analysis and came up with the different morphological consideration, and finally based upon our consideration we came up with a particular composition, like this particular composition is best. Then we try to compare this with respect to the multi blend and the hybrid blend. Like in this case you see, if I use a PLA, I am getting the melt flow rate or melt flow index of 28. If I am using a PVC, it is giving a melt flow rate or melt flow index of 25. This is these some average values. Then if I use PLA with PVC, some different values. Then PLA with 15% PVC, with 20% PVC, with 25% PVC, I am getting a different values for the melt flow rate. Similarly, putting the magnetite powder Fe3O4, we came to know about their melt flow rate. Similarly for the wood dust. So based upon the optimum consideration, we try to develop the filament and try to see what is the effect of all these composition in 10%, 15%, 20, 25, and of course with the multi-blend on the peak load, peak elongation, break load, break elongation, peak strength, break strength, percentage elongation at break, percentage elongation at break, young modulus, their stress value, their strain value, and try to optimize the situation. Of course the stress strain curve for all cases are also mentioned, and for all cases the hardness value using the show D scale that has also been plotted. Then to ascertain whether this material will be fair enough at the different temperature conditions. So again the thermal analysis for all cases with the different proportion of the PVC and wood dust, and what we observed with the addition of the wood dust, the thermal behavior was improving like anything, right? And then the reinforcement of the magnetite powder helped to improve the magnetic behavior. So it was compared for the multi blend as well as for the just PLA and the 20% magnetite, right? So finally the observation is like using these type of the combination, I can actually think of primary, secondary, tertiary recycling, and this helped me in developing a smart product. Like for some of the viewers who are not that comfortable in primary, secondary, tertiary recycling, just the idea is in primary recycling I am using a magnetic way, I am using a mechanical way of mixing. In secondary recycling I am adding some material along with the mechanical means to enhance some property. In tertiary recycling I am putting some chemical into it so that the bond characteristics are improved, and in quaternary recycling we are basically working on the energy recovery process. So in this case what we have done is mainly the secondary recycling, which has improved most of the mechanical properties. So I believe with this any customized filament for 3D printing can be prepared, and we can use it for n number of applications. So this is the overview of standard operating procedure for working on the uh, different commercial 3D printing process. I hope you all enjoyed this, and in our coming session we will see some more example of using this type of the hybrid or multi-blend material. Thank you very much.